Okay, so what is the transistor? Transistor is actually the combination of two names, that is transistor. Actually, this is transformation of the and resistance. So that is actually the combination of two words. It is the word transistor is taken the some word from the transform and this other part from the resistance. So it is actually the shifting of the resistance. Okay. So transformer is transistor is used to transform the resistance. It has a two part. Okay. One is part is input, one is output. So if I divide into two part, okay, it shifts the resistance actually. The small resistance into high resistance, or high resistance to small resistance, to increase the voltage or input voltage. So with the help of if there is a input, it use if for example there is this is the input wave. Okay, what will be transistor may amplify this. Okay. So it is actually control, and that is also not only used for amplify. Sometimes it used for degrade it, and sometimes it is also used as a gate too, लॉजिक गेट्स जैसे नॉट गेट में भी ट्रांजिस्टर यूज होता है, ठीक है, हम वो बाद में पढ़ेंगे कि कहाँ कहाँ इसका यूसेज है. एक्चुअली ये क्या काम करता है, आपकी रेजिस्टेंस को ट्रांसफॉर्म करने का काम आता है. तो दैट्स व्हाई दैट इज डिफाइंड एज अ ट्रांजिस्टर. ओके, गॉट इट. समटाइम वी मे एम्पलीफाई इट, या आप इसके अपोजिट भी पॉसिबल है, ठीक है. So there are different purposes of uses of this transistor. Okay, how we actually we sandwich, we combine two diode PN and PN, the transistor made from the like a two diode which are PN PN or NP and PN. Mean you may say that this is like this is equivalent to आप ये देख सकते, you can easily observe that these are the combination of PN diode and NP diode. Okay, this combination is okay. Okay, so this is the transistor. Okay, and transistor has 3 parts. This part is defined as emitter, base, okay. Emitter जो emit कर रहा है, active part, this central part is defined as a base, and last part is defined as a collector. The same is true for this. This is E emitter part, this is base, and this is a collector. Emitter is representing by the E, and base is representing by the B, and collector is representing by the C. Okay. Okay, so this is the this is the actually the transistor is made by manufactured by this this method. Pn, that will be at left side, that is a Pn, mean that will be emitter, combination of emitter and base, and this is combination of, so that are actually the combination of 2. Okay. 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 कुछ क्वेश्चन है? Yes, P is a P-type semiconductor, N-type is a N-type semiconductor, and N mean which contains the electron as a majority carrier, and P mean holes as a majority carrier, a positive charge. Okay. The size of the N, it will be a very small as compared to the P. Okay. Size and doping of base is a very small. Okay. But emitter and collector are doped. They are heavily doped. Emitter and collector will be heavily doped. Okay. And what will be so light doping semiconductor is that base will have, yes, will have small majority carrier. Okay, will have small majority carrier. But be silent, please, please. But emitter and collector will be heavily नहीं sorry, but heavily, please be silent, but heavily doped semiconductor is that emitter and collector will have large in numbers, large in number majority carrier. So that is the different. ठीक, ओके. सो मेजोरिटी कैरियर जो हैं एमिटर में और कलेक्टर में ज़्यादा होंगे, बट बेस में दैट विल बी अ वेरी फ्यू. ओके ओके. So if I connect, these are type of the semiconductor is called PN transistor. Oh, sorry, these are called PNP transistor, and these of transistors are called NPN transistors. Okay, so that will be a PNP transistors, and that will be a NPN transistors. So that will be a difference. Okay. 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 ओके, इट इज़ अ वेरी क्लियर अप टिल येट. ठीक है, इस ये लाइट कैरियर है, वो हैवी अडॉप्ट है, सो दे आर अ मेजोरिटी कैरियर्स. ओके, सो ओके, दैट आर द कम्बिनेशन ऑफ टू टाइप ऑफ द डायोड. यू मे से दैट. ओके, फर्स्टली आई ट्राई टू एक्सप्लेन. लेट्स सपोज P and P. Okay. If I connect a battery, yes. If I connect a battery, in numbers, majority carrier. In numbers, and that are a majority carrier. Majority carrier. Okay. Be silent, please. Please. Okay. If I connect a battery, yes, if I connect a battery with this, okay. If I connect a battery with this, what will be happen? Plus is connected with the plus P. अगर मैं सिंपल बैटरी लगा रहा हूँ, अभी इस तरह ट्रांजिस्टर नहीं कनेक्ट करते, लेकिन मैं अभी आपको इसके फंक्शन को समझाने के लिए ये लगा रहा हूँ. ठीक है, अगर इफ आई कनेक्ट द बैटरी विद दिस, व्हाट विल बी हैपन? नो, P के साथ that will be a, this will be a forward bias, yes, and this will be a. So this will be combination of, because I have stated that that is combination of PN and PN, that is combination of two transistors that are PN and P. Please try to understand the working of this. Okay. 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 So then what will be happen? This will be plus with the plus, and negative is connected with the negative, and this is connected with the negative is connected with the positive and positive. So it means actually this transistor will behave like a two diode. One will be a forward bias and one will be a reverse bias. You may say that this is actually equivalent to, yeah, please. Yes, this will be actually equal to okay, like this transistor, okay, because oh sorry, okay, for same battery, the one will be treated as a forward bias and one will be treated as a reverse bias. So you may write bias, okay. Got it? Okay. And that is not only the constraint to this circuit, that is also true for NPN transistor. In NPN transistor, this is about PNP for NPN. The same thing will be true for NPN transistor. But either in here the polarity of the battery will be reverse, okay. Here plus minus, here will be a minus plus, okay. Please be silent. This will be equal to this. So this will be a reverse bias. Okay, so मैंने ये बताया कि actually this is the way. That's why one transistor will be a forward bias, one transistor will be a reverse bias. Okay, if I replace it with this is the basic diagram. Okay, if I use the double battery, this will behave the same. This will be at the same. If I use a yes. Now I have applied the okay. Now I have used the double battery. Actually, I have already told in transistor we use the double battery. But firstly, I have used one battery to only explain the what is actually the working of why that are equivalent. Oh. नहीं, that is a right. मैंने उसे गलत नहीं कहा. Okay, so वो भी आपने यूज करना. बोर्ड में कुछ जगह है इसलिए कुछ अरेज करके आगे लिखना पड़ता है जी. अब हम इसके आगे जा रहे हैं कि आगे ये वर्किंग कैसे करेगा. वो ठीक है, वो डायग्राम रेज नहीं करनी. दैट इज ट्रू. मुझे रेज इसलिए करनी पड़ी, बोर्ड में एक लिमिटेड सी जगह. Okay, now what will be happen? Now we will discuss. That is the proper जो है. Okay. Okay. So this is like the previous circuit, but actual circuit is like this. Okay. I have already told this will be a forward bias. This is in the previous I have explained this is forward bias and this is a reverse bias. Okay. So due to this positive, this will be the majority carrier will be moved toward majority carrier whole R will move toward toward the N region, because that are connected with the negative terminal. I have already explained. Okay, the base is negatively connected and this is a positive connected. So majority carrier will be moved toward the N region. Okay. That is actually the combination of P and NP diode. मैंने यही बताया कि ऐसे ही है ना, दो डायोड करना, क्योंकि ये पीएनपी डायोड है, ये एनपी। ये अभी आगे करूंगा तो आपको ज्यादा एक्सप्लेन हो जाएगा, ठीक है। सो अब यहां से क्या होगा इस इक्विवेलेंट सर्किट के मुताबिक, ठीक है, मेजॉरिटी कैरियर विल बी मूव टुवर्ड दी एन टर्मिनल, ओके। और यहां क्या होना चाहिए, इट मस्ट बी रिकम्बाइन विद दी नेगेटिव इलेक्ट्रॉन। जब यहां से यहां, इसको मैं ग्रीन, इसको मैं एम्पलीफाई कर देता हूं, ठीक है, समझने के लिए इस साइड वाले को, ठीक है। सो इट विल बिकम मैंने इसे जरा समझने के लिए इसे बड़ा करते हैं, ताकि जिन लोगों को नजर नहीं आता उनको नजर आ जाए। ओके, यहां आपके पास यू हैव अ मेजॉरिटी कैरियर, these are the here these are a majority carrier, here are a here are a here are electrons, okay. But for example, beta please, here are a electron, here are a holes in a majority, but not proton is the thing, but holes are a positive carrier, majority carrier, okay. These are the positive charge, these are the negative, these are the hole. When they transform here, they will recombine with the electrons, and that become a neutral. होल के अंदर इलेक्ट्रॉन गिरेगा, खत्म हो जाएगा, ठीक है। सो दे बिकम अ न्यूट्रल, ओके। अच्छा, ये तो कुछ हो जाएंगे न्यूट्रल, बट दीज आर द थिन, दिस लेयर इज अ थिन and doping is a very light, okay. There are two conditions. Since doping size and doping of the base is small, so number of electron will be a very few. So recombination of electron with the holes will be a very small. So only some are, matlab fuse 2 or 3 or 5 have ability to recombine. Remaining all will be transformed. Some will be transformed here, and remaining all will be transformed to the collector. Okay, got it? Due to, okay, very few in number. Large in amount. So very few will be recombined. So very few will be recombined. Okay. Now because recombine will be low, okay. So these these hole will be transformed from here to in this region, collector, because okay, they will be due to so from here they will be transformed to, majority will be transformed to here. So here is positive hole are already in majority. Now these are also come here, okay, and so then that will be collected here. So so collected in collector, and so this will be moved toward in this way, okay. Okay, so this will be moved in this way. So circuit will be how this okay. So it will be collected here. So these electron will be collected in this collector region, okay. So, and this will be transformed from 1 minute प्लस चार्ज होल्स, okay. पहले भी होल थे और दूसरे उधर से आ गए, और okay. So what is the way of the current? This was a forward bias, this will be a reverse bias, okay. Okay, so that means your current will be flow like this. Okay, please try to understand. There are two junctions, this and this. PN, there will be two depletion region and there will be a two junctions. Okay, it will behave a forward bias like, and it will be behavior like a reverse bias. Okay, so J1 and J2, because there are two junctions J1 and J2, current will pass through the this will be emitter current, and that will be passed from the collector, and that will be also the this is a forward, and this is a reverse. This is a emitter current. This will be a collector current. This will be a base current. But base current will be approximately a very small, because I have already explained that is the region is a very small. But IB will be very, very, very small, because base region is very, very small. Because it is a very small, in 1 minute. Because this region is a very small, okay. Because these regions are a very, very small. No, why there? Okay. Okay. Because base region is a very small, so because when electron will get the potential due to this negative potential. Okay, because hole will be attract towards the negative potential and it will accelerate. And आपको पता है जब आप accelerate होते हो तो आपकी speed kinetic energy बढ़ जाती है. When kinetic energy will be increased, तो ये यहाँ stop, क्योंकि ये region small है तो ये collector पे चला जाएगा. Okay, so that's why collector जो base current है वो that will be a very small. Collector region. ये वाला because these are not forward bias, because I have this is n region. लेकिन करंट फ्लो करेगी, करंट इसलिए फ्लो करेगी वो मैंने आपको रीजन बता दी. ठीक है, क्योंकि दिस इज अ स्मॉल, सो दैट्स व्हाई दैट विल बी ओके. So incoming current will be divided into the collecting current and base current, and then that's why input there will be effect on input voltage and output voltage. Because जब करंट में चेंज आएगा तो V इक्वल टू आई आर के बराबर होता है, तो रेजिस्टेंस में चेंज आएगा तो वोल्टेज में भी चेंज आएगा. वो हम लेटर एक्सप्लेन करते हैं कि वाई दैट विल बी एम्पलीफाई और डी एम्पलीफाई. ओके, यहां तक तो ये है ना. और ये कैसे, ये जो है ये फॉरवर्ड बाइस है, ये रिवर्स बाइस है, तो कलेक्टिंग कैसे होती है, अभी तक तो ये बात ही की है. IE, IB, IC. IB mean emitter current, IB mean base current, and IC mean collecting current. Very few in amount. One minute. नहीं निकलती बेटा, प्लीज अभी. ठीक है, ओके. सो दैट विल बी, इसका भी एक दफा बना लें फिर करते हैं. ठीक है, अच्छा इसका क्या बनेगा, इसी का भी इस तरीके से है. चलो मैं डायरेक्टली बता दूं. ठीक है, तो आपके पास ये आएगा, तो करंट आपके पास, आप इसको ट्रांजिस्टर में This is a way to represent the diode. One minute, एक मिनट, इसको दूसरी डायरेक्शन में भी वो भी ठीक है, लेकिन इस डायरेक्शन में जरा okay, this is a B, E and C. PNP पे आपकी करंट पॉजिटिव से इस तरफ जा रही है, ठीक है. सो दैट्स रिप्रेजेंटिंग बाय द एरो ऑन दिस, लाइक दिस. ओके, जी. IB is a very small because the base region is very small. Base region, I have already explained that base region is very small. Okay. अच्छा, यहां अगर आप देखें तो क्या हो रहा है, मेरी बात सुनो, इधर से इसको समझ लो. इसके तीन पार्ट है, इमीटर, कलेक्टर एंड बेस. बेस दरमियान में थी, ये इमीटर है और ये कलेक्टर है, ठीक है. क्योंकि करंट इमीटर से इस तरह जा रही है, इमीटर से इस तरफ जा रही है, आगे की तरफ. ओके, तो इसको हम जो है क्या कहते हैं, इस वजह से इसको इनसाइड नोटेशन, ये पीएनपी डायोड को रिप्रेजेंट करता है. तो सो दिस इज अ पीएनपी. और अगर इन बैटरी की पोलैरिटी को अगर इस तरह जिसमें करंट फ्लो होता है, इससे ट्रांजिस्टर का एक्टिव मोड कहते हैं, एक्टिव mode. When current, because current will be flowing like in entire circuit, तो इसको एक्टिव मोड. अगर इस पोलैरिटी को चेंज कर देते हैं, यहां रिवर्स बायस कर देते हैं, तो देन दैट विल बी डिफाइंड एज अ नॉन एक्टिव मोड. लिख लें. नहीं, सिंपल है, इसमें करंट जा रहा है ना, क्योंकि ये वाला जो है अगर फॉरवर्ड बायस है और ये रिवर्स बायस है, तो देन करंट विल बी फ्लो फ्रॉम हियर, ओके, एंड दैट विल बी दी एक्टिव मोड. लेकिन अगर यहां आप नेगेटिव इसकी पोलैरिटी को चेंज कर देते हो, ये भी इस तरह की पोलैरिटी रहती है इस तरफ, तो नो करंट विल बी फ्लो. अगर नो करंट विल बी फ्लो, देन दैट विल बी डिफाइंड एज अ, अगर इस रीजन की पोलैरिटी को, बैटरी की पोलैरिटी को चेंज कर देते हैं, तो इफ नो करंट फ्लो ड्यू टू change of polarity of battery, non active mode of transistor. So that will be defined as a non-active mode of the transistor. Got it? Okay. For acha, the same thing will be revised for this, but little bit change here. If we draw for this, Okay. अच्छा, in this case electron will be transformed here, जैसे वो यहीं जैसे उस तरह explain किया है. In this case the whole was there was a whole movement. In this case there is the same movement of the electron, but according to conventional current, the current will be okay. One minute, please. Electron will move from, this is E, this is B, this is C, okay, from E to B and B to C. In the case as whole are moving from this is E, this is B, this is C. Okay. In this case, electron are moving E to B and C. Okay. But conventional current according to conventional current direction will be, हम पॉजिटिव की वजह से कंसिडर करते हैं ना, तो करंट विल बी, डायरेक्शन विल बी C to B to E, मतलब हमारी रिवर्स वाइज कंसिडर करती है. ओके, सो दैट्स मीन electron will move from E to B, B to C, and but conventional current for conventional current C to B, B to E. Okay, so it means the so this will become yes. In this case, this is equivalent to this. This is N or base are the junctions. There are two junctions, J1, J2. Okay, and current will be moved from, yes, current कैसे move करेगी? From here. So this is IC, this will be IB, and this will be IE. And that is the reason this circuit will be representing by the NPN transistor will be representing by the this will be representing by the same as it. Okay. Yes, Shamil. What will be the difference? This is B, this is E, and this is C. So what will be the difference? नहीं, दैट विल बी द रिमेन्स द सेम। हियर ई इज इनवर्ड, यहां करंट जो है ई से क्या आ रही है, बाहर की तरफ आ रही है, तो सो दैट विल बी रिप्रेजेंटिंग बाय द ओके, सो दैट इज फॉर दैट इज पीएनपी डायोड। अगर इस तरह का डायोड दिखाया जाए तो ये पीएनपी डायोड होगा, अगर पेपर में इस तरह का दिखाया जाए तो ये एनपीएन डायोड होगा। सो दैट्स द अबाउट द एनपीएन एंड पीएन डायोड।